Hello everyone, the March equinox is coming up, and while I was arguing with some flat earthers about the equinox, it occurred to me that people just don't seem to understand how the heliocentric model works. In combination with their belief in a flat earth, they just assume that the equinoxes are impossible on a ball earth. So I figured, why don't I try to explain how the equinoxes are possible in a heliocentric model. Usually when I try to do this in the YouTube comment section, I refer to this picture, as I think that this picture shows it quite well. When you start at the winter solstice, you see the Earth's axis is in line with the Sun and the North is tilted away. While the Earth is orbiting counterclockwise, you can see that the Earth's axis is always pointing in the same direction, and after half a year it's on the other side of the Sun with its axis in line with the Sun, this time with the North tilted towards it. At the equinoxes, the Earth is halfway between the solstices, and the longitude lines over the Earth are always in line with Earth's axis. But only on the equinoxes are you in a position that the longitude lines at the sunset side and the sunrise side of the Earth are exactly on a 90-degree angle with the sun's rays. And this is why the sunrise is due east for everyone and the sunset is due west for everyone. In a scale model, that would look like this. Here you have the Earth in the winter solstice position, just like that picture I showed, and it's going to rotate counterclockwise, and the axis is going to stay in the same position. Now the key position, of course, is this one. This is the March equinox position, and these longitude lines should be on the outside here, exactly in line with Earth's axis. Now in a close-up that would look like this. Here you have the North Pole, South Pole, and there's a longitude line exactly halfway through, as you can see here. So basically, as it's in line and the sun would be on the side here, shining in a 90-degree angle on the longitude line. Now I did make a darkened model just to show you how that would work. Here you have our artificial sun shining on the Earth in the equinox position, illuminating half. Now, here again the Earth is in the winter solstice position, North Pole tilted away, and the globe is illuminated half, just as in this picture here. So, it doesn't really matter how you rotate the Earth, but finally you will get to this position where the terminator line from the daylight and nighttime is exactly halfway and in line with the North Pole and the South Pole, and so is the longitude line. So everyone on this longitude line would see the sun set due west. It doesn't really matter. Here you have a low picture from the South Pole, and as you can see, everyone on this line has the sun to due west. So basically, this is how it works on a heliocentric ball model with the equinoxes. Thanks for watching.